Today, we're solving one of the most popular interview problems on LeetCode, threesome. You're given an integer array called nums. Your task is to find all unique triplets such that the three indices are different. The sum of the three numbers is exactly 0. And most importantly, no duplicate triplets are allowed in the final answer. Let's understand the threesome problem clearly using the given examples. Example 1. Input. Nums equals -1, 0, 1, 2, -1, -4. First, we sort the array. After sorting, it becomes -4, -1, -1, 0, 1, 2. Now we start checking for triplets whose sum is 0. Take -1, 0, and 1. Adding them gives -1 plus 0 plus 1 is equal to 0 valid triplet. Take -1, -1, and 2. Adding them gives -1 plus -1 plus 2 is equal to 0 valid triplet. Other combinations may also give 0, but they repeat the same values in a different order. Since the problem does not allow duplicate triplets, we keep only the unique ones. So the final answer is -1, -1, 2, -1, 0, 1. The order of the triplets does not matter. Example 2. Input. Nums equals 0, 1, 1. Let's try all possible combinations. 0 plus 1 is equal to 2, which is not 0. There are no other triplets to check. So the output is an empty list, because no triplet satisfies the condition. Output. A. Example 3. Input. Nums equals 0, 0, 0. Hey, there's only one possible triplet. 0 plus 0 plus 0 is equal to 0 valid. Even though there are multiple zeros, we only include one unique triplet. Output. I0, 0, 0. In this video, we'll solve LeetCode problem 15, threesome. We'll understand the idea step by step using an example and see how the two-pointer technique helps us efficiently find all unique triplets that sum to 0. We are given an integer array. Our task is to find all unique triplets such that the sum of the three numbers is exactly 0. Each index must be different, and the final answer must not contain duplicate triplets. Let's take example 1. The input array is -1, 0, 1, 2, -1, -4. Our goal is to find all combinations of three numbers from this array whose sum is 0. The first and most important step is to sort the array. Sorting allows us to use the two-pointer approach and also helps us skip duplicates easily, which is required by the problem. After sorting, the array becomes -4, -1, -1, 0, 1, 2. Now we will fix one number at a time and search for two other numbers that complete the sum to 0. We start by fixing the first number as -4. To make the total sum 0, the remaining two numbers must add up to +4. We place one pointer at the start of the remaining array and another at the end. We test different pairs using the two pointers. Every possible combination with -4 results in a sum less than 4, so no valid triplet is found here. We move to the next number. Now we fix the number -1. The target sum for the remaining two numbers becomes +1. Again, we use two pointers, one from the left and one from the right. We check -1 and 2. Their sum is 1, which matches the target. This gives us our first valid triplet. -1, -1, 2. After finding a valid triplet, we move both pointers. We also skip duplicate values to ensure the final answer does not contain repeated triplets. Let's solve the threesome problem. We are given an integer array, and our goal is to find all unique triplets whose sum equals 0. The key challenge here is efficiency and avoiding duplicate triplets. First, we sort the array. Sorting is critical because it allows us to use the two-pointer technique and easily skip duplicates. Now, we iterate through the array using an index called current index. This value represents the first number of our triplet. Before proceeding, we check for duplicates. If the current value is the same as the previous one, we skip it. This ensures we do not repeat the same triplet. Next, we place two pointers. Left pointer starts just after the current index. Right pointer starts at the end of the array. Our target becomes the negative of the current number, because we want the sum of the three values to be 0. Inside the while loop, we calculate the sum of the values at the left and right pointers. If the sum matches the target, we found a valid triplet. We store it and move both pointers inward. After finding a valid triplet, we skip duplicate values on both pointers to ensure uniqueness. If the sum is smaller than the target, we move the left pointer to the right. If the sum is larger, we move the right pointer to the left. We repeat this process until all valid triplets are found. Finally, we return the list of unique triplets. Now let's run the solution. All test cases are passing successfully. Submitting the code. And accepted. Efficient, clean, and no duplicate triplets. If this explanation helped you understand the threesome problem clearly, don't forget to like the video, subscribe for more LeetCode solutions, and I'll see you in the next problem.